Bismillahir Rahmanir Rahim. Assalamu alaikum. Hello and welcome to this video. Today we're going to cover the first lesson in logarithms, and this session will be divided into two parts. So guys, let's start the first part. To explain the meaning of logarithms, we need to remember two things. Logarithms are another way of thinking of exponents, and exponents and logarithms are inverse operations. What do I mean by this? Suppose we have three numbers, 3 and 8. I can use those three numbers in order to write this relationship. 2 to the power of 3 equals 8. And this notation is called exponential notation or exponent notation. And here is called the base. 3 is called the exponent, or sometimes we call it the index, and 8 is called the argument. Another way in order to write a mathematical relationship using those three numbers is using logarithms. It means if I have log to base 2 of 8, that will be 3. And that simply means in the 2 to power 3 equals 8. Or you can ask another question. 2 to what power equals 3? What is the log of 8 to base of 2? It simply equals 3. And here we have 2 is called the base, and 3 is called the exponent, and 8 is called the argument. Here we have two equivalent mathematical statements. The first one to the left-hand side is written in a logarithm notation. And how to read it one more time: log to base b of n equals x. The base is b, n is called the argument, and x is called the exponent. The second mathematical statement, which is actually equivalent to this statement, is written in exponent form. Here, guys, we have some restrictions for b, the base. If we're talking about logarithms, the base must be greater than 0. It means it must be a positive number. يبقى هنا b must be a positive number greater than 0. And b doesn't equal 1. Doesn't equal 1 because 1 raised to any power simply equals 1. It doesn't mean anything. Okay? The second, x, the exponent, can be any number. يعني هنا the exponent can be positive, can be negative, can be fraction, can be decimal, even can be 0. مثلا if I say 3 to the power of negative 2, it's a real number, which is 1 over 3 to power 2, which is equal to 1 over 9. Okay, if I say 3 to power 0, 3 to power 0, we know that it's 1. يبقى هنا x, the exponent, can be any real number. Okay, the argument must be positive. يبقى هنا n must be greater than 0. Why? Simply because if I say 2 to the power what? Equals negative 2. Let's think about an exponent gives the result of negative 2. An exponent which makes this. And let's think about an exponent x which makes this equation true. If I say 2 to the power of negative 1 simply equals 1 over 2. Okay, let's say مثلا 2 to the power of negative half. It will be 1 over root 2. So anyway, the argument must be positive. So this one, يا ولاد, is not correct. يبقى هنا the argument in the logarithm must be positive value greater than 0. In this exercise, we're going to convert exponential form or exponent notation to logarithmic form or logarithm notation. Here, guys, we are given the mathematical statement in exponential form. 3 to power 2 equals 9. And now I need to convert this exponent form into logarithmic form. So how can I do it? Here, guys, we have the base is 3. يبقى هنا 3 to what power equals 9. How to write down this using logarithm notation? Here, guys, log to base 3 of 9 equals 2. And let me write down how to read it. يبقى هنا log to base 3 of 9 equals 2. طيب, let's go to the second one. We are given that 2 to power of negative 2 equals 1 over 4. يبقى to convert it into logarithmic form, we need to think about 2 to what power equals 1 over 2. يبقى هنا it could be written like this. Log, and the base will be written as a subscript right here. It will be log to base 2 of what? Of 1 over 4 equals negative 2. طيب, let's go to the next one. We are given that in 10 to power 4 equals 10,000. طيب, to convert this exponential form to logarithmic form, it will be log, and the base هنا هيكون 10 of 10,000, which is equal to 4. Let's do this example, and by doing this one, it will be very easy to have an exercise to solve that. And now, guys, let's go and solve the first example. Here we are given logarithm notations, and we are required to write the following logs in exponential form, and then find the value of x. Right, let's start with the first one. Here we are given that in log to base a of log to base 2 of 16 equals x. Right, how to write it in exponential form? It will be very easy. Just take this arrow. So it means in the 2 to power x equals 16. Right, here, guys, we need to think about 2 to power x equals 16. I need to make equivalent bases. أنا أعرف إن 16 simply equals 2 to the power 4. يبقى هنا it means إن ال x equals 4. طيب, I can find it out also using the factorization. It means if I have 16, let's factorize 16. 16 division by 2 equals 8. One more division by 2 equals 4. And then division by 2 equals 2. And for the last one, division by 2 equals 1. So يبقى هنا 2 is repeated 4 times. It means 16 equals 2 to the power 4. And now let's go to the second one. B log to base 3 of x equals 3. طيب, how to convert it in exponential form? Just make this arrow. It means in the 3 to power 3 equals x. And that means in the x equals 9. Sorry, x equals 3 to power 3, which is 27. Okay, the third one, we are given that in the log to base x of 25 equals 2. Right, how to convert log form into exponent form? It will be very easy. Just make it like this. Take this arrow from the base to argument. It means in the x to power 2 equals 27. And by taking the square root of both sides, يبقى ال x هنا equals 5. Some students would say, يا مستر لا, we know that in the x to power 2 equals 25, معناها in the x equals positive or negative 5. Yes, actually, it's correct. But in logarithms, I'm going to take only the positive value. The negative value will be excluded. Okay, let's go for D. We are given in the log to base 4 of 1 over 16 equals x. طيب, how to convert it into exponent form؟ يبقى هنا 4 to power x equals 1 over 16. يبقى هنا 4 to power x equals 1 over 16. طيب, in order to solve this exponential equation, أنا عندي هنا 4 to the power x equals 16 can be written, 1 over 16 can be written like 16 to the power of negative 1. And 4 to the power x equals 16 itself can be written like 4 to the power 2 all to the power of negative 1. It means in the 4 to power x equals 4 to power 2 multiplied by negative 1 equals negative 2. It means in the x equals negative 2. And now let's take the second example in order to master the log form and exponential form. Here, guys, we are required to convert exponential form into exponent form. And we need to find out the value of each variable. طيب, okay. يبقى هنا log to base 3 of 81 equals x. It can be written like 3 to the power x equals 81. And I know that in the 81 equals 3 to power 4. يبقى هنا x equals 4. The second one, log to base 6 of y equals 3. طيب, let's convert it into exponential form. It will be 6 to power 3 equals y. That means in the y equals 6 multiplied by itself 3 times. You can use a calculator to find out the value. Afterwards, we have C. أنا عندي هنا log to base A of 512 equals 3. It means in the a to power 3 equals 512. Here I can use the cubic root. It means in the a equals 8. Fourth one, we are given that log to base 4 of x equals negative 3. Type to convert it into exponential form, take the base 4, raise it to the power negative 3 equals x. It means in the x هنا equals 4 to power of negative 3 simply equals 1 over 4 to the power of 3, which is equal to 1 over 64. Let's go for E. Log base 6 of A equals 6. It means 6 to power of A equals 6. It means n A equals 1. We are given log to base 2 of x equals 1. It means 2 to the power of 1 equals x. And that means n x equals 2 to power 1 simply equals 2. Okay, G, here we have log to base 10 of 1 equals y. It means 10 raised to y power equals 1. طيب, هنا يا ولاد 10 to power what equals تاني 10 to power of what number equals 1. I know that in 10 أو any number raised to power of 0 equals 1, and that means in the y equals 0. Question H, we have 10 to the power of A equals 0.0001. And here, guys, in order to solve this exponential equation, I need to rewrite it. It means in the 10 to power of A equals 1 over 10 to the power of 4. Okay? And that means and 10 to the power of A equals 10 to the power of negative 4, and that means in the A equals negative 4. But let's pay more attention to this question. We are given that in the log to base 3 of negative 9 equals z. Okay, طيب let's think about this one. أنا عندي هنا 3 as a base raised to power of z equals negative 9. Can we think about a number z makes this equation true? Actually, no, there is no such number. So here, guys, we have no solution. Okay, and actually, we cannot have a negative argument. If you remember, I told you that the argument must be a positive value, must be greater than 0. طيب, let's go to the last one. Here we are given in the log to base 2 of x equals 4. That means in the 2 to power 4 equals x, and that means in the x equals 2 multiplied by itself 4 times, which is... In order to deal with logarithms, we have some properties or some laws. Now we're going to cover the 3 basic laws of logarithms, and let's start with the first one, and the first one is called the product law. Actually, if I have a single logarithm, يعني هنا we have a single logarithm, and the argument is a product of two factors. This single logarithm can be expanded and can be written like the addition of two logarithms. It means if I have log to base a of xy, so xy هنا a product of two factors. So this single logarithm can be written as a sum of two logarithms. But هنا يا أولاد I must have the same base. It means هنا log to base a. So when I expand it يبقى هنا I must have the same basis. طيب, one example for this. If I have, for example, log to base 2 of 15, so 15 can be written like 3 multiplied by 5. So I can write it to be like this. I'm going to say مثلا log to base 2 of 15. This one can be written like log to base 2 of 5 multiplied by 3. And this single logarithm can be written in the form of the sum of two logarithms. هنا log to base 2 of 5 plus log to base 2 of 3, and this is called the product law. The second property is called the quotient rule. And here we have almost the same. Whenever you have a single logarithm and you need to expand this logarithm, it will be the difference of two logarithms. Okay, an example for this, if I have, for example, log to base 3. ليه 3 خلينا ناخد okay, let's take 4 over 5. So that will be equal to, أنا هنا عندي the quotient of two factors. يعني ممكن I can write down this log to be log base 3 of 4 minus it will be the difference of two logs. طيب, the third one is called the power rule. The third property is called the power rule. And here if I have log to base a of b raised to the power k. هنا يا أولاد الباور k actually for b. يبقى هنا b is raised to power k. So what shall I do with this? يبقى هنا k can be the coefficient of the entire log. يبقى هنا equals k multiplied by the same log but without the power. طيب, one example for this. If I have log to base 5 of 3 to the power of 2. يبقى هنا it can be written like this. 2 will be the coefficient. يبقى هنا 2 multiplied by log to base 5 of 3. And this way I can get rid of the power of the argument. طيب, we have something we need to pay attention to. For example, what is the difference of log to base 5, 3, all to power 2? Okay, can be written can it be written to be 2 log 5 of 3? Actually, no, it cannot be written like this. This is a mistake. Why, mister? Because هنا it 2 is not for 3. 2 is a power for the entire log. لكن I can use the power rule only لو الباور هو للargument. Only the argument. يبقى هنا I cannot use. And here we have 3 special cases I need to be aware too. The first one, log to base A of A equals 1. Okay, and we have restriction. A must be positive value and doesn't equal to 1. It means log to base 7 of 7 simply equals 1. ليه يا مستر؟ Because 7 raised to power 1 equals 7. يبقى هنا any log to base A of A it will be 1. يعني مثلا log to base مثلا 10 of 10 simply equals 1. Okay, log to base x of x simply equals 1. The second property is that log of 1 simply equals 0. Okay, يعني log to any base of 1 simply equals 0. ليه؟ لأن a to power 0 equals 1. Okay, the third one is log to power a of 1 over x simply equals log to power of x to power of negative 1, which is equal to negative log a of x. Fine. Let's take an example and let's explain it step by step. Let's say I have log to base 3 of 1 over 6. This one, يا أولاد, can be written like log to base 3, and 1 over 6 can be written like 6 to the power of negative 1. And according to the power rule, I can write down the negative 1 to be the coefficient. يبقى هنا negative log to power 3, to base 3 of 6. And we're going to prove it later, inshallah. One more property of logarithm is called change of base. But it means what? If I have log to base A of B, and I need to change the base of this log, actually it can be done. And it will be what? It will be log to base C, for example, if I need to change it to be base of C, of B over log to base C of A. And we're going to prove this property, inshallah, during the second part. Right, for example, if I have log to base 2, هنا يا أولاد I have the base to be 2. طيب, I can change the base if I don't like 2 مثلا, for example, or I can change it to another base in order to make it easier in solving. Okay, طيب, how can I do this? طيب, let's think about any base. I need to مثلا change this base to be 5. يبقى هنا it will be log to base 5 of 5 division by log to base 5 of 2. And please don't confuse it to the quotient rule. The quotient rule is a little bit different from this, and by solving more exercises, it will be very easy to differentiate between them. And now let's have this example on the laws of logarithms. The first one. First, I need to write as a single logarithm and find the value of each log. طيب, listen يا ولاد. The first one, let me write it one more time. I have log to base 10 of 5 plus log to base 10 of 20. طيب, if I make it one single log, it will be easier to be solved. طيب, what do we have right here? We have the sum of two logs with the same basis. يبقى هنا the sum can be minimized to be the log of the product of the two arguments. It means it will be log and base must be the same. 2. 5 plus 20, it means 5 times 20 as a single log, which is equal to log to base 10 of 100 And now guys, it can be solved. يعني 10 to power what equals 100. Let's take it right here. Let me ask you. Log of base 10 of 100 equals x. Type, what could be the value of x? And that means يعني 10 to power of x equals 100. So simply x equals 2, and this is the value of the logarithm. And by using the rules of logarithms, طيب, let's go to the second one. Let me write the second one more time. So here you get, what do we have? We have a log to base 2 of 10 minus log to base 2 of 5 equals what? Type. Here we have the difference of two logarithms with the same bases. يبقى عارفين ان the difference can be changed to be the product of two factors. يبقى هنا I need to keep log to base 2, and it will be the difference, sorry, it will be the quotient of 10 over 5. And that can be simplified to be log to base 2 of 2, which is equal to 1. In order to find it, out, you can think about the log like this. يبقى هنا log to base 2 of 2 equals x. And يلا, let's convert it into exponential form. يبقى 2 to power x equals 2 and x equals 1. So the value of this logarithm simply equals 1. And now let's go to the third one, and it's a little bit tricky. طيب, let me write it down one more time. هنا we have log to base 5 of 3 plus, let's pay more attention to this log, 4 log to base 5 of 2 equals. Okay, some students would say, والله يا مستر, هنا we have the sum of two logarithms with the same base. So for sure, يا مستر, will be product rule. Actually, yes, it's a product rule, but هنا I have something I need to get rid of first. أنا عندي هنا 4 as a coefficient. Okay, يبقى هنا in order to apply the quotient rule or the product rule, I must get rid of the coefficient. طيب, how to get rid of the coefficient? سهلة يا مستر. We can use the power rule. طيب, let's write down the first one. We don't have any problem with that. So it will be log to base 5 of 3 equals. And now يا ولاد, let's get rid of this coefficient. طيب, let's take it. Let's undo this. Let's undo this coefficient. يبقى هنا I'm gonna take 4, make it 2 to the power 4. يعني هنا it will be what? It will be log base 5 of what يا مستر؟ أنا عندي هنا 2. Take the coefficient and put it as a power. هنا 2 to the power of 4. Okay, it seems to be easier. هنا log to base 5 of 3 plus log to base 5 of 2 to the power 4 simply equals 16. And now let's do it. يبقى هنا I have what? I have the sum of two logs with the same base with no coefficients. يبقى خلاص already I can convert it into a single log. It will be log to base 5 ل 3 multiplied by 16. يبقى هنا equals log to base 5. يبقى هنا 48. Okay, and I cannot find the value of this log mentally, so I'm gonna use the calculator. Let me explain how to use a calculator to find out the value of any log. Okay, and now let's explain. And now let me explain how to use a calculator to find out the value of a logarithm. Here guys, we are required to find out the value of this logarithm اللي هو log to base 8 of 40 log to base 5 of 48. طيب, let's use a calculator. Here I need to use the button right here. Okay, can you see it? This one. Okay, يبقى هنا log. Okay, log, and let's write down the base. The base is 5, and then the argument is 48. So it will be approximately equals 2.405, which is equal to 2.41 approximately. So the value of log to base 5 of 48 simply equals 2.41. And now let's do exercise number 4, or example number 4. I need to write in terms of log A, log to base A of x, log to base A of y, and log to base A of z. It means I have two logs. Let's focus on the first one. Here we are given log to base A, and the argument is a little bit complicated. Here in the argument we have x squared, and we have y and z to power 3. لكن هنا what is the relationship between the factors inside? Actually multiplication. يبقى هنا we're going to have the product rule. طيب يبقى هنا the first thing, let's split the argument. يبقى هنا عندي a, let me write it one more time. يبقى هنا log to base a of x squared times y times z power 3. طيب equals. And now let's expand this log. I have a single log, so right here I have 3 factors inside, so I can expand it to be the sum of 3 logs. طيب, the first one will be log base a of x squared, and then plus. The second one will be log to base a of y. Okay, and the third one will be log to base a of z power 3. Okay, equals. Here guys, what do we have? We have هنا log to base a of x to power 2. يبقى هنا the power can be taken to be the coefficient. It means إن هنا log. So the first log will be written like 2 log to base a of x plus. The second one, هنا we don't have a power, but هنا keep it like it is, plus the third one, I need to get rid of the power, take it as a coefficient, it will be 3 log a of z. And this is the answer in the simplest form. Type, let's go to the second required. Here guys, we are given this log. Let me write it one more time. يبقى هنا I have log to base a of x over y to power 3. طيب هنا يا مستر we have a product of two factors. يبقى هنا this one can be splitted to be the difference of two logs, which is correct. يبقى هنا هعمل log to base a of x minus log to base a of y to power 3. Are we done with the question? Actually, not yet. طيب, the first log, I don't have any problem with it, so I will write it like this. لكن second one هنا has power. يبقى هنا الpower can be dragged to be coefficient. يبقى هنا log to base a of y. And this is the answer in the simplest form. In this example, we had a single log, and the required is to expand the single log. But in the next one, we're going to have the opposite. يعني هنا I have two logs, I need to combine them in a single log. يبقى هنا let's write down the logs into a single log, okay, and find the value of each log. طيب, let's start with the first one. I have a log to base 2 of 5 plus 3 log to base 2 of 3. طيب, هنا I have the sum of two logs. يبقى هنا I need to combine them in a single log in order to solve the question. طيب, here guys, before I use the product rule, I need to get rid of the coefficients. يبقى هنا the first log, I don't have any problem with it. Plus, and here 3, let's undo. 3, it will be a power. Let's take it to be a power of the argument. It means this one will be log to base 2 of 3 to power of 3. Okay, and now let's write down this one. Log to base 2 of 3 to power 3 simply equals 27. And now guys, I have the sum of two logs without any coefficients, so I can use the product rule. It will be log to base 2, and the argument will be 5 multiplied by 27. And for this one, I need to use the calculator. So this one will be log to base 2 of 135. And let's use a calculator to find it out. 2 of 135, which is equal to 7.076. It can be 7.08. Okay, ولاد. Done with the first one. Let's go and solve the second one. We are given the difference of two logs. Let me write it right here. 2 log to base 5 of 3 minus 4 log to base 5 of 1 over 2. Right. Here guys, before I combine the two logs using the quotient rule, so that means take 2, make it as a power ل 3. يعني هنا تبقى 3 to power 2. هنا log to base 5 3 to power 2 minus log to base 5 of 1 over 2 to power of 4. Okay, which is equal to, يبقى هنا log to base 5 and 3 power 2 equals 9 minus log to base 5 and here 1 over 2 to power of 4 equals 1 over 2 to power 4, which is equal to 1 over 16. And here, since we have the difference of two logs with the same base without coefficients, هنا I can use the quotient rule in order to get a single logarithm. So it will be log to power of to base of 5, and here we have 9 over 1 over 16. I need to modify this one. يبقى هنا log to base 5, and here we have 9 multiplied by 16, and that will be log base 5 144. And now let's use a calculator to find it out. Log base 5 of 144 equals 3.1 approximately. And now let's go to the question 3, and it will be the last question for this session. Third one, I have the sum of two logs without coefficients. يبقى هنا it's 100% the product rule, even without simplifying anything. So it will be log to base 10 and open a bracket. It will be root 3 multiplied by 4 to the power of 5. And we can use a calculator directly to find it out. So it will be log to the base of 10 root 3 times 4 to the power of 5, which is equal to 3.2 approximately. By solving this exercise, guys, we're done with the first part in the first lesson of logarithms. We still have the second part. See you inshallah, and thank you so much.